This is Jim, and welcome to today's training. Today I will introduce the encoder axis configuration and post axis configuration. Our 6V is a CAD PLC, but it also supports high-speed input and high-speed output. This is the basic information about the encoder axis and post axis in 6V. We support for encode axis, we support linear mode and rotary mode. It can support 8-channel high-speed input, single phase, and 4-channel AB phase input. And also we have touch pop function and preset function. For the post axis, we also support linear mode and rotary mode, and we have 4-channel high-speed output. And in software, we can configure the homing mode and use software to do the online debugging. Now let's first check the encoder axis. Here in project management, we have this motion control axis. We right click to add the axis and double click axis to enter this page. This page, you can see we can configure the axis type as bus servo axis. It's a CAD axis, and local post axis, local encoder axis. So here we need to select local encoder axis. And next step here have the unit conversion settings. The picture shows the default setting. It means 10,000 poles is 1 unit. It means when our PLC receive 10,000 poles, our counting value will add 1. So this is the default setting, the relationship between the user unit and post numbers. Okay, and the next we need to configure the counting mode of our axis. For the linear mode, we can set the forward limit value and negative limit value. When the value beyond the limit, it will keep a limit value and didn't change. And also we can configure it as rotation mode and set the cycle of the rotation. Default is 660 because usually for example, we need to record the angle of the encoder. We will use this 360 degrees. And here, this is the counting curve of the rotary modes. It means when the counting value achieves 360, and if the PLC receive post input again, and the counting value will change to 0 and go from 0 to 360. This is the rotary mode. And the next, here we have some other function. For example, touch pop enable and preset function. And this here also have the counting modes. We need to configure it. We have 3 selection in our software: single phase, AB phase, and post direction. After selecting the counting mode, we need to select the signal source here with this selection. And for other function, if you want to use it, you just need to check this button and select the terminal to use it. And here in program, we need to put this HC counter function block to receive our counting value. And this is the access configuration of my environment. Here I set the lottery mode as lottery mode, and the cycle is 360. And this is the user unit. First, my encoder, the PPR of my encoder is 400. It's AB phase input signal. So here I select counting mode as AB phase and I connect phase A to X0 and phase B to X1. Because it is four times frequency. So here, when the encoder rotates one road, it will output our PLC will receive 1,600 pulse. That's why I put this value here. And also I set the value, set the user unit as 360. So it means when the encoder rotates one load, here our counting value will increase 360. And now we can check this video. You can see when the value achieves 360, it will back to 0 and increase again. This is the configuration of the lottery mode. It will show as no, it can output the velocity, but it can't output the acceleration of the input signal. And HC preset, if you want to use preset function, we need to use this HC preset function block. Here we have 4 input signal in a function enable signal, and the trigger edge presets position and axis number. For the trigger edge, if we set it as 0, it means we use the software to preset the axis. So here you can see when I trigger this HC preset, the counting value will be set to this value, this position value we set in our preset function block. And if we set the trigger edge as 1, it means we will use the external input signal to preset our counting value. And which X terminal we need to use, it depends on this preset setting in the axis configuration page. So here, if I set it as 1 and enable this function block, the value will be preset to preset position when the PLC gets signal of X2. And the compare function, we need to use this HC compare function, this one. And here have the introduce of the input signal. Position is the compare position we need to set. And output enable. 0 means no hardware output, and 1 means enable hardware output. And the last, here we have this interloop map. This terminal, this input is used to bind our interlooped program name. And this function is used for when we enable this function block, and then the counting value achieve the compare value, we will the PLC will execute the interrupt program and output the Y terminal. If you bunch interrupt program in this terminal. And for the output signal of the Y terminal, we have two way to output it. We can set it as time. For example, it means the Y terminal Y0 will turn on for 1 second when the counting value achieve the compare value. And here, if we select units and set, for example, 20 units, it means the Y0 will turn on until the counting value at 20, and then the Y0 terminal will turn off. So this is if you join the AC60 training before, you will see this function is similar to HC compare function in Cortex. Okay, so this is the some function about the encoder axis. I think it's very easy to use. Set the rotary modes and the counting mode counting signal source, and enable this prop function, reset function, compare function according to your application. If you don't need, if you don't have this, you don't have to enable this function if you don't need. And the next, I will introduce the post axis. Here, for post axis, we set the axis type as local post axis and select one group to use. Here, Y0, Y2, Y4, and Y6 is our post output, and the Y1, Y3, Y5, and Y7 is our direction output. And the list setting, unit conversion. List setting is it means, for example, with the default setting, that means when we set the target position as 1 unit in our function block, for example, relative motion or absolute motion, then the PLC will output 10,000 pulse for 1 unit. And here, for example, we can convert this user unit to the special unit we need. How to understand? For example, if our motor rotates motor rotate one rod, the rod move, for example, 10.5 mm. So here, if we want to set the unit in our function block as mm, here we can set this as 10.5, and here this should be the PPR of the motor. So with this setting, if we want to move our mode, for example, if you want to move the load to move 20 mm, then in the function block, in the motion function block, we can directly set the target position as 20. So it will be more convenient. We can set here and don't need to do the calculate in our project. And this parameter is similar to encode axis. So we can skip this. You can see here we can set the forward limit, negative limit, and the speed limit. acceleration limit, some parameter. And for the here have this homing mode. This is a built-in function of the software. We can see uh, here have the list of the homing modes we can support. And for each homing mode, here we have a picture to show how this homing mode works. And here have settings about the signal. It depends on your machine, structure. For example, you have positive limits or home signal and or negative limits. You can select here. So it can after select here will display the responding homing mode. And below this picture we have the uh, sensor limit signal. So here we can connect the limit sensor to our input side and configure it here. When we use these homing modes, please ensure uh, the move direction is correct. Otherwise, the motor will move in wrong position when we trigger the home function block. And this is uh, this video will show how this homing mode works. First, we enable the post axis with this MC power function block, and we use this jog function to move uh, to some place. Okay, move to here, and now we trigger this uh, homing MC home function block. Okay, now you can see the axis is begin to move in forward direction because as you can see in this picture, when we trigger the MC home, it will move with the high speed. Where is the high speed? This is the high speed. This origin return speed. And here, because I connect Y2 to X2, so and here you can see I configure X2 as the positive limit signal. So when I turn on M2, it means we simulate the motor reach the positive limit sensor. Okay, now the motor is reach the sensor positive sensor. Then it will begin to rotate in backward direction with speed 2. But this speed is negative value, you can see. And where is the this speed 2? It's here. This orange return approach speed. This, as you can see in this picture. And when will the motor stop? The motor will stop when it's leave the limit sensor. So here, when I set the sensor signal at 0, the home HC home here, you can see the output of the MC home will turn on. That means we have already finished the homing mode, and the motor is stop in our home position, and here you can see the position information of the axis is changed to 0. Okay. And here have a special homing mode, 35. In this homing mode, we don't need to configure any limit signal. And if we configure it as homing mode 35, as long as we trigger the MC home, the motor, the the driver, the position of the axis will be set to the home position directly. And the last, I will show you the online debug function. Here in axis, we have this online debug interface. This online debugging interface only used for post axis and bus axis, and encoder axis don't have this online debugging function. We enter here, enter servo debugging and enable an axis. So here we can jog our axis with the jog speed and do some motion. For example, relative move. Here we set the target position and target velocity. Also, we have absolute positioning preset function. It's just same like the HC preset function block. Okay. Also here we can reset the arrow and stop the axis. And also here have a control mode. We can set two points and make our axis move between these 2 points. Okay, so this is the online debug function. We can, for example, when we begin to, when we need to do some measure, for example, the move direction of the motor, we can use this online debug. It will be more convenient. We don't need to write code, write function block to test. Okay, so this is our today's content. It's very easy. If you have used AC60 before, you will find the configuration step is very similar. And do you have any question? If you have question, you can type in this chat group, chat box, and our next training will be next Tuesday, and it is the last training. I will introduce the ECCAD axis configuration, and our online exam will open next Wednesday, and you guys will have about 1 week to join the exam. And also, please remember to submit your homework. After this training, we will update our training group to this YouTube channel. You can check the recording here.